Hello there, everybody. In this video, we're going to be going over fractional exponents. This is our fifth and final lesson going over properties of exponents. The first was over multiplication properties, the second was over division properties, third was special properties, and fourth was scientific notation. If you want to review any of those, you can go find the corresponding videos on our channel, but if you're looking for fractional exponents, you're in the right place. So, the most important thing to remember is that a fractional exponent indicates a root. You can see over here on the right the formula for fractional exponents. It states that a to the power of m over n is equivalent to an nth root with a to the power of m inside of it. Now this one over here is pretty important. I'm not sure if there's an official name, but I like to call it the standard or the neutral fractional exponent. Because if you notice, it looks like there's nothing going on, right? It looks like you didn't put an exponent value in the n or the m places. But actually, that's exactly what it's supposed to look like when you have a half. And that is because, well, firstly, this 1 goes to the a, and as you know, anything that's to the power of 1 is just that number. So if I have 3 to the power of 1, it's just 3. So we don't need to write the power of 1 next to this a because that's the same thing as just saying a. Now, for this power of 2 on the bottom, that would usually go to whatever the root is, like nth root to say that's the power of that root. But in this case, you don't need to put anything because the square root is the basis. Because you usually call this just a root as like a general term to say it could be like the cube root, for example, if it has a tiny 3. But when you're just writing it by itself, we call it a square root. And that is because whenever you see this symbol, it's kind of weird. Whenever you see this symbol, that is the same thing as saying it already has that tiny 2, because that's the default. That's why it's known as the square root, because it has that tiny 2, like when you square something to the power of 2. So that's why this half exponent looks like nothing has been done. It's just the general term. A to the power of 1 is still a, and a root with a 2 is just what you normally write the root as. So that's why I like to call it like that neutral or that standard, because it's like the very basis. Well, you just write it and it seems like you're not changing anything because that's usually the default of how you would see those exponent values written in normal problems. But when you do have other values, you are going to need to put the n and the m in the right places. Now, it can get a little bit confusing because it's like, how do I remember where to put the m? How do I remember where to put the n? But I like to remember it as, okay, m is on the inside, n is on the outside, as in it's inside the square root or it's outside the square root. It's technically just the root. So I usually just abbreviate that or like shorten it to top in, bottom out. For the top fractional exponent value goes inside the root, and the bottom fractional exponent value goes outside the root. For me, that works pretty well, but if you need a way to abbreviate it in your head, I would say try to find something else like that. So, when you have fractional exponents in an exponents problem, apply the exponent rules as you would normally. Now we're going to have a series of examples to demonstrate that. So, this is our first example. It's just writing a root using this fractional exponent. So simplify x to the power of 3 over 4. If you need to look at an example or at the formula, it's right here on this fourth little line on this formula chart. But remember, top, in, bottom, out. So we can put the x inside, and we can put a square root symbol. So the top goes in and the bottom goes out. So this top value of 3 goes inside the square root, inside the root, and this bottom value goes outside the root. So as you can see, this x to the power of 3 over 4 goes to a power 4 root, I believe is how you say it, with an x to the power of 3 or x cubed inside of it. Now we can see some examples where we actually have to work with the fractional exponent in the problem. Now, remember, try to distribute this exponential value first. So this power of 4, put it to the x to the power of 2 and y to the power of half first and foremost. So we can split this up into x squared, and then you have the 4, and y half, and then you have 4 again. Now, based on the power of a power rule, we are going to multiply these exponents together. So this turns into x2 times 4 to give you x to the power of 8. And this y value with the half, interestingly, turns into y half times 4, which actually won't give you a fraction at all, because then you'll get y squared. And that's because multiplying something by a half is the same thing as dividing it by 2. So half times 4 equals 2, because 4 divided by 2 equals 2. So interestingly, when you write this answer, you get x to the power of 8 and y to the power 2. So in your final answer, you don't actually need to put a square root of anything at all. So remember, just because it has a fractional exponent does not necessarily always mean that you're going to end up with a square root anywhere in your answer. So here's our next example. This one looks a little bit different because instead of one of the values inside the parenthesis having the fractional exponent, it's outside. So once again, we want to follow this distributive property. We want to take the half, we want to give it to the y, we want to give it to the x, and we want to give it to the 36 with coefficient. So now we can write all of this out. We have 36 to the power of half. We have x squared to the power of half. And we have y to the power of 4 and to the power of half. Now, let me do these two variables first. So once again, this power of a power rule states that we are going to multiply these exponent values together. So we're going to take x2 times a half, or x squared divided by 2. And either way, regardless of whether you multiply that 2 by half or just divide it by 2, you're going to get x to the power of 1. Now this y value follows a similar pattern because we're going to do y power of 4 times half, which is the same thing as saying 4 divided by 2. Once you do that, you're left with y to the power of 2, or y squared. Now, going back to this 36, as you can see, there is no other exponent value to influence this half. So in this case, we are going to write it as a rational exponent. So once again, top in, bottom out. And, this one has half as a fractional exponent, and you know that whenever it's a half, it's just a normal square root. Now, we can add all of these together to find our answer. So let's start off with our coefficient, the square root of 36. Well, we can plug that into a calculator, and once we do that, we see that the square root of 36 is 6. Now we can bring our x to the power of 1, and once again, when something is to the power of 1, it's just itself. So that's the same thing as just saying x, so we can just say x. And then we bring that y squared over. And we're left with a final answer of 6x y squared. Alrighty, now it's time for some independent problems. So read this question, read the answer choices, pause the video, and work this out yourself. I'll give you just a moment. Alrighty then, you should have paused the video and worked it out. And now let's do it together to see if you got the right answer. So we're still following the same format. We're taking this exponent and we're distributing it to everything inside the parentheses. So s to the power of 4, done to the power of 4, and t half done to the power of 4. Now this can turn into s 4 times 4, which will give you s to the power of 16. And this t turns into t half times 4, or 4 divided by 2, to give you t squared. Slap those two values together and you get a final answer of s to the power of 16, t to the power of 2, or in this case, answer choice B. And once again here, this half exponent did not end up needing to become a root. So just be careful with the order of operations so you make sure you do the problem in the correct order. Now, here's another independent practice problem. Once again, read the question, read the answers, solve it on your own, take a minute to pause the video, and work it out. Alright, moment over. Now let's work it out ourselves and see if you got the right answer. So, like always, distribute. Distribute, distribute, distribute. Very, very important. So, we got the 64 with the half. We got the x6 with the half. And we got the y to the power of 8 with the half. Now, in the last problem that was similar to this, we did the exponents first, so that way I could introduce this. Well, the variable exponents first. This time, let's do the coefficient first. So, 64 ends up becoming a 64 squared. Because there's no other exponent to affect this, meaning our final exponent value is still that half. So it's still a rational exponent. And then the top goes inside the root, and the bottom goes outside the root. Half fractional exponent is the same thing as just the normal square root. So we can turn this 64 in a square root over to our calculator, and once we do that, we get 8. Alright, now let's work on the x value. So here we have x 6 times 1/2, or 6 divided by 2. Either way, we're going to get x to the power of 3, also known as x cubed. We can do the same thing with this y value. We get y 8 times half, or 8 divided by 2, and end up with y to the power of 4. So if we take all of our values together, we end up with 8x to the power of 3, y to the power of 4, or in this case, answer choice A. Alrighty, and that is it for this lesson. Once again, this is the final lesson in this Properties of Exponents mini video series. If you need to check out any of the videos on that, go over there and review or learn them. If not and you're all good, then thank you so much for sticking around. A quick, very important final tip, just in general, remember to separate your coefficients and your variables because the exponent rules will only apply to the variable terms. Your coefficients are your normal numbers, so they're going to have normal mathematical processes. Meanwhile, your variables with the exponents are going to be the ones that follow these special properties of exponents rules. So don't just use the rules unanimously. If there is anything with an exponent in the problem, make sure that you're only using them to what is applicable. Other than that, that is all I have to say. Thank you so much for sticking around, and I do hope that you found some sort of help from this or you found some sort of value in it. If you want, you can check out any of the other videos where we go over different tutoring topics. But other than that, I have nothing else to say. Thanks for sticking around, thanks for watching this video, and have a lovely day. Goodbye.